Alrighty, let's get started. Thanks so much, everybody, for joining today. Our topic today is what's new in data observability. And with me, I have John Morrell, who's the Senior Director of Product Marketing here at Upscale Data, and also Chris Cozzi, who is the Director of Product Management here at Upscale Data. So John will go through a short presentation, and then Chris will do a live product demo. And hopefully we have given enough sacrifices to the demo god so that we don't have any issues there. But let's take it away. And John, why don't you get started?
Great. Thank you, Loretta. Welcome, everybody. I'm going to go over just a few things really quickly to kind of sort of set the stage in and around data observability and some of the things that we're doing with the product. Tell you a little bit about what's new and then hand it over to Chris so he can really show you all the whiz-bang great new stuff that we've got in the product. A lot of you people have joined this webinar today because you have these data challenges, whether it's the fact that you've got data all over the place in many different spots and you're trying to find better ways to use it, whether your data stack has gotten far more complex and sprawled and different pieces of it and different components of it that make it hard to understand and control and manage. And there's also a big talent shortage out there. A lot of new people are coming out of school or learning data engineering techniques and getting degrees in it. But there's still a big shortage of data engineers out there in this world. So it's really difficult to kind of keep up with your data and keep up with your data infrastructure. And so what ends up happening is when you sort of feel these particular pains that we talked about a moment ago, is your architecture and your data can end up with what we like to call operational blind spots. And they continue to work their way through, whether that's things like changes in your schemas, issues in around throughput, performance, and latency, whether it's around making sure your data is synced between all your various systems and is saying the same thing, and that's called data reconciliation. Or whether that's making sure that your data is of the highest level of quality so that your end users can trust it and understand it and work with it effectively. Whether it's also in and around understanding how your data pipelines are working and are they working effectively? Are they breaking down? And if they are breaking down, what are some of the problems with that? There's also performance issues that you need to look at on an operational side, because that impacts things like your throughput and your latency, or whether or not the fact that the data actually got to the right people at the right time. And then there's also things around what's called data drift, which is another form of data reliability, and the fact that sometimes your data, whether it's from errors or whether it's for real reasons, right, may drift out of a particular bounds that you're looking for. And you need to be able to detect that and understand why that's happening. And then the last thing, and we're going to talk a lot about this today, is spend. So imagine if you were able to have a platform that could do all of these things for you, right? So you have a complete 360-degree view and visibility across your entire grid or your entire data stack. You could quickly understand your blind spots, see issues inside of your blind spots, and resolve problems inside of there. And your data could end up being of a great level of quality, and so you can certify them as gold standard. And you're able to observe and understand, and your data engineers and your data teams are the ones to understand when problems happen and get alerted to when problems happen. And you can be the first one to fix them. You don't have to wait until the users start yelling and screaming that the data isn't good. You can see and detect errors right away and fix them immediately. And with the ability to kind of detect these issues and understand them and be able to drill down into them and understand the root cause of them and actually prevent them, then you as a data team are doing less data firefighting. And now you're actually working on great, innovative new projects. And you can also help understand better your costs, save yourself money, keep you from getting cost overruns. And then so therefore, throughout all of this, you're able to achieve your SLOs and your SLAs, your service level agreements that you have out with your business teams. So what is data observability? Well, underneath the covers, data observability really needs to be able to understand and give you visibility into these four areas. First of all your data assets, whether it's tables or views or files, right? Understand and give you visibility into those. Help you understand your data pipelines. How are they operating? How are they running? Are they running effectively? Are there problems? Understand your data users. What are users doing with the data? How often are they touching it? What types of queries are they running on that? And then lastly, understanding your data infrastructure. How is my infrastructure running? What are my costs looking like? What is my performance looking like? So all four of those areas are critical for data observability. But data observability also comes in three specific use cases. One is data reliability. And that's kind of a thing that data observability kind of hung its hat on, right? Data reliability was a lot of the key critical first aspects of data observability. But that's not all data observability is all about. There's also spend intelligence. You know, the cloud has come up with new cost models and spending models, as a lot of you know. It's elastic, it's on demand, it's pay as you go, pay for what you use. And so understanding what you're spending, how you're spending it, and who is actually spending your resources is really important to monitor and to understand so that you don't get cost overruns, so that you don't get bills that are out of control at the end of the month. And then also there's operational intelligence, because data health isn't really just only around, hey, do I have reliability or do I have quality, but do I have the right performance? Do I have the right level of throughput in my systems? And how can I make sure that my underlying infrastructure, my underlying system can support the levels of performance, latency, as well as throughput that I really need? And how can I go about fixing that if it's not? And so data reliability, spend intelligence, and operational intelligence all focus on different aspects of your data health. Data reliability looks at, again, data quality, pipeline monitoring, freshness, detecting anomalies like data drift that we just talked about, monitoring and alerting to data problems, and solving those problems when they do occur. Spend intelligence looks at sort of like the cost aspects of everything you're doing, whether that's optimizing your costs, it's giving you visibility into costs at different aspects, costs within your platform or different aspects of your platform, costs within your various business entities, whether that's departments, users, different groups, your costs by particular user, your costs by various queries that are being run in the system. And once you get that visibility, then you can start doing some really, really interesting things. You can do things like create chargeback models in order to put costs back associated with the various business entities that are working with it. You can set up guardrails to make sure that resources are used effectively, so that you're not spending like crazy, and that you can shut down things and control things better so that you can keep costs from getting out of control. And it also helps you build forecasts and budgets going forward so that you can keep within your predicted spend models. Operational intelligence looks at how are you consuming your resources within your data infrastructure, even within your cloud data warehouse, right? Or cloud data lake. What performance am I getting? How do I administer to the system? How are my assets being utilized? What queries am I running against the systems? And then doing some similar things that I just talked about with spend intelligence, like setting up guardrails so that resource utilization doesn't get out of control and it maintains certain levels. Understanding how effectively do I need to size my systems? Do I need to build bigger warehouses, or can I go with small ones? Do I need to build out a larger cluster, or can I stick with the type of level of clustering that I have today? So it helps you right size your systems for the types of performance and aspects that you want with them. And then lastly, operational intelligence also helps you, gives you recommendations in terms of how to do this. And Chris will show you some of this in a demonstration that we could look at a system and say a Snowflake data warehouse and say, hey, you know what, you really should be using an XL rather than an L, or maybe you can get away with using an L rather than an XL. So Excel data gives you all of this in a single platform. So we talked about having all of that data from users, data from your assets, data and information from your data pipelines, and data information from your infrastructure. We surface all of that information through our data observability platform, and we help correlate that in what we like to call our multi-layered data approach. But we surface all that information in dashboards, in tools, and user interfaces that focus on the very particular problems or use cases that you're trying to solve, whether that's data reliability, spend intelligence, or operational intelligence like we talked about. So what's new in our data observability platform over the last couple releases? And I'm talking in particular about releases 2.5, 2.6, which both came out recently in the last couple months, as well as release 2.7, which is imminently going to be available on the market. So from a data reliability standpoint, we've got this great new view called Asset 360, which helps you better understand and give a complete comprehensive view about what's going on inside of any particular data asset that you're working with. We had enhancements in and around helping you apply data policies in bulk, so you can apply them to many assets, multiple assets at the same time, which really helps you scale out your data reliability efforts. We have new combined KPIs and policy score charts that allow you to keep, again, this 360-degree view of what's going on with your particular assets and understand what's going on as an overall data health standpoint. And in spend intelligence, this is an area that we've been expanding rapidly with the product in the last couple releases. And this really gives you far more granular detail in and around your cost and your spend. And Chris will show you what some of that detail looks like, so you can really understand where your spend and where your cost going to, and to be able to better understand and work with that, and to be able to really control where you're going to do that. We have greater chargeback granularity, so you can divide up and understand and set up models for chargeback by, again, any of these same levels of dimensions within your platform or users, et cetera. We've got standard stock monitors, things that automatically register with your data infrastructure and surface alerts if these particular problems occur. And then we have also recommendations that help you say, hey, you need to right size your data warehouse or your data lake. And you should do that in this particular fashion in order to get the best possible cost models out of it. In the operational intelligence side, we also set up a new recommendations dashboard and have also recommendations that we automatically surface for you. And so just like the ones with spend intelligence, but this takes a little bit of a different approach. Rather than looking at recommending configurations by spend, we look at recommendations based on the type of performance characteristics or throughput characteristics you need out of your system. We also have, and these recommendations are platform specific. So we know what platform we're working with, whether that's something like Snowflake, Databricks, or Hadoop, and we tailor the recommendations to that specific platform so that you can work with it and understand it. We also have a brand new query studio and the ability to monitor what queries are going on within your system so that you can better understand who's using what resources, what queries are using what resources, and how can I better optimize some of these queries and execute them effectively. And then we've got all these infrastructure alerts in and around your compute and the rest of your infrastructure so you can surface problems or surface potential problems when they might be happening. Also, we did also add a couple new platforms to our data observability platform in Kafka and MongoDB. So what we're able to do is give you a lot of great new insights into your platform. If you take a look at things like Snowflake, we've now got spend and cost, compute and storage utilization, query monitoring, as I mentioned, all these alerts and these guardrails you can set up, and the configuration recommendations. With Databricks, it is very much a lot of the same things, right? But we surface these insights in a different way because we know you think about and work with Databricks in a different manner than you will Snowflake. So we're able to do things. So rather than give you things like query monitoring, we give you workbook and workspace monitoring because that's what Databricks is all about. And on Hadoop, we also surface these same types of insights as well, understanding how you're using your resources, understanding where you may have wasted resources, do things like anomaly detection on how your system is operating. Is it moving out of bounds? Is it moving, less? Simulators as well, so you could potentially simulate how you would use resources to understand the type of performance and output that you would get from that. And again, also configuration recommendations. So why is this all important to you? Well, from a data reliability standpoint, now you're getting much more holistic data visibility. Asset 360 and the data cadence and other things can give you better understanding of the overall asset performance. You can use the cost monitoring and alerting to help you eliminate cost overruns so that you don't get that bill at the end of the month that's going to blow your CFO's mind, right? You can understand where you're spending, where your costs are going, and drill down and look at this at a very granular level to not only charge back to these groups, but then you can also understand to say, hey, these particular groups are using more resources than they should be allocated, and understand and put guardrails in place to better understand that. You can also use these operational insights to see how my platform is performing to help you better deal with the complexity of your platform and complexity of your overall data stack. And then lastly, we give you better optimization and control so that you can use things like recommendations and guardrails to optimize the way you want your platform to run. So with that, I'm going to hand things over to Chris, and he will take you through the demonstration. Chris?
Thanks, John. Let me pop up my screen here. Cool, so I should be sharing now. Yeah, so as John mentioned, I want to talk through a little bit of the functionality that we've released over the last few months. That's definitely more than we can cover in a 1-hour webinar, so I'm going to spend most of my time on the spend and operational intelligence side in the context of, a little investigation use case walkthrough. But I did want to talk a little bit about data reliability up front. I wanted to show that Asset 360 and talk a little bit about the dimensions of reliability we track for a little bit of context to that part of the new features as well. So starting in data reliability, let me get my Zoom controls out of the way here. So starting in the product area of data reliability, this is really where users go to understand the data in their platform, begin to observe it, and then start implementing reliability and checks to ensure that data is of sufficient quality for its end users. And the Asset 360 feature is one we're pretty excited about that I wanted to touch on here, but I'll start with a little bit of context into the dimensions of reliability John spoke about to see how they're actually apparent within the tool, and then roll up into this new 360 dashboard we've been speaking about. So what you're seeing here is one of our entry points into data reliability. This is more of your day-to-day view. How are my assets performing? Are there any I need to be concerned about? One of the metrics we look at for this is how reliable is the asset versus how highly used is the asset. So the idea here would be, as I start to see things drift into this upper left-hand corner, I want to move those right into the high reliability quadrant. And that's done by assessing reliability, which we do apply this coverage through a set of policies, of which we have 4 types. So hopping into an example policy here. This is a policy that's actually been executed. I may have arrived through this entry point in the context of an alert. So I have policies in play. I'm alerting on them. I'm seeing them in Slack. I'm getting directed into the application to understand where my quality might be dropping. So policies, we categorize those into 4 types. They're the dimensions John talked about. So data quality policies, data reconciliation policies, data drift policies, and then schema monitoring policies. For the most part, these follow a similar pattern. So we have a set of rules we're assessing on the policy. We then summarize those up into an overall score on which you can take action through setting thresholds on that score. So in this case, I've dropped into a failure state because anything under 85% successful is failure. This policy here in particular is a data quality policy. So this is where we capture the data engineering or business rule focused checks. So some of the examples I've pulled out here are validating primary keys for uniqueness and null issues, doing some numerical range matching on percentage fields, and then even an example here of validating that this data matches an associated reference file. So from here, users can then drill in and understand potential violations. So looking at this reference file check, I can see that 20% of the time I'm actually seeing values in this field which don't match to our reference files. So this is sort of the outcomes. I'm going to jump into the configuration because I do want to highlight how we operationalize these, which is just pretty important to understand in our platform. So it's worth noting, I chose a couple rule definitions, but we have a whole lot of other ones that are essentially applied out of the box, but then as needed, you can drop into more custom coding, whether that's, more of the analyst focused SQL or dropping into pure, data engineering focused user defined code, which could be Python, Scala, Java, JavaScript. So more of those data engineering focused pieces of code. We also help you seed this with some recommendations we have out of the box based on profiles of the data that we're capturing. But talking a little bit about how we operationalize these, there's a few aspects of this. One, it's obviously important that we can run these efficiently. So while you can monitor on full data sets, we often see these used in pipelines where some incremental strategy makes a lot of sense, whether that's based on an ID or a date or a partition in the data. And then it's how you operationalize these in pipelines. So you could take a passive approach. You could schedule this, just monitor data quality over time. But where we see a lot of value driven with our clients is where you actually take these policies into your pipelines themselves and use them as a decision point. There's a few options you have as far as taking a decision. I think these are often also paired together. Is one, you could abort or what we call circuit break your pipeline. So if you meet a certain threshold of quality, you might want to abort it and investigate. This is also then often paired with some persistence capabilities we have. The idea here is as that decision point in your pipeline, instead of just doing a binary, continue on or abort, you can pair this with some essentially record routing where we can save off either the bad records or both the good and the bad records and use those in downstream pipelines. So essentially let the good records continue passing through. But for the violations, save those off for investigation or reprocessing, or in some cases, this even involves going back to a third-party vendor, sending those records back. So that's what we mean when we think about actually operationalizing these inside of pipelines. And then we have as you'd expect a variety of alerting and notification channels. I mentioned Slack. This could also go to email and other places. So that talks a little bit about the data quality side. Just to cover the other three dimensions really quickly here. Reconciliation is all about how the data is moving through your pipelines. So think of an example where you're processing data from raw to staging to some gold warehouse tables. Reconciliation policies are what's going to let you ensure that that data is flowing through correctly, both from the record count perspective as well as the actual validity of the data. So the rules here are more about the joining and comparison between two data sets. Data drift, more statistical checks. So based on the data we're profiling, are we seeing changes in it over time on those variety of profiling metrics, and what changes potentially too much where you'd want to start being alerted on it and investigating why your data is changing over time. And then the last one, schema drift. This is really all about quite a simple opt-in. And then from there, we'll start monitoring additions of columns, removals of columns, changes in data types in both database tables as well as files. So bringing that all together was really the idea behind the Asset 360 dashboard, which is what I'm showing right here. And the idea here was we got a request a lot from our customers to more easily summarize the overall reliability of an asset. So I walked through those policies and the different dimensions to try to give some context that there's a lot we're monitoring here, potentially multiple dimensions as well as multiple policies on top of those. So it's kind of a lot to package all up and really understand how reliable is this asset. So we've done some work to summarize that. We've introduced an overall reliability score on an asset, as well as essentially using that as an indicator to understand the performance of that over time. So as these policies are executing, as we're doing these checks, we'll consistently be updating that score and giving some indication of, is it going up, is it going down, what's changing in my system. And then this starts to be the basis of messaging out on these assets. So from this single asset level, you start to get a sense of, at the platform level, am I improving the quality of my data as a whole? And it also becomes a potential piece of information where we see customers who bring these results and this reliability score into externally facing data catalogs, things like allocation, where there it can be for socialization of reliability, as well as a potential decision point in those tools themselves, as they have capabilities for flagging and messaging out to the end users, the end consumers of the data, or through those catalogs. So that was a pretty quick run through of reliability. I'm going to cut over to the spend and operational intelligence pieces now, but obviously we have a lot more going on in here that we hope to cover in other webinars. All right, so I'm going to walk through this area a little bit in the context of an investigation. It's actually something we saw internally here at Excel Data that we investigated ourselves. And along the way, I'm going to touch on some of the new enhancements and capabilities we've had in those 2.5, 2.6 releases that John mentioned. So to set the stage a little bit, I'm going to work for a data-driven enterprise. I'm a platform owner in charge of making sure that the users of my platform are consuming resources responsibly. I don't want cloud costs, spiraling out of control. I'd like best practices followed. And I really need that complete visibility into the usage of the data platform. Now, a lot of places we see this start with our clients is understanding how these platform resources tie back to the organizational units or the business units of their company. And this is done in our tool with an area we call Chargeback, which really involves setting up that hierarchy of organizational units, which can be fairly complex. They can be nested, but at the end of the day, you're then tying these to specific cost centers. These are associated to the organization units, and this is how we essentially allocate the platform usage up to the different business areas in these organizations. So this is structured as a hierarchy. I think the big call out here is a little bit on the flexibility on how we can actually assign these costs. So if I spin up a little example one here really quick. The heart of configuring the cost center is really telling us how to allocate the costs you're using in these data platforms to the variety of organizational units. And this can be done at several different levels. So in Databricks, for example, you might have an entire account that rolls up to a cost center. You might have just portions of account which rolls up to a cost center. In our case here, for Databricks, that's at the workspace level, sort of underneath the accounts. And then our newest addition in the last release is actually to take advantage of tagging that might already be done in your Databricks account to clusters and pools, and using those as a way of associating costs. And we can also do this with Snowflake. It looks pretty much identical. The main difference there is for Snowflake at the resource level, you're working with artifacts that make sense for Snowflake. So the warehouses where you're storing the data, kind of things that align with how they charge you. But putting my platform owner hat on for a second, with this organizational structure in place and the mapping of the resources, I can see that the sales organization here has a big spike in data. And I think John alluded to some of the granularity we introduced here recently, which is being able to drill, pretty deeply into where that's coming from. So I can understand that it's tied to the cost center here, where the sales team is doing their customer sandboxes, their customer demonstrations. Going a little further, I can see this is all happening in Snowflake, one of our Snowflake data sources. And it's really allocated to the consumption, the use of Snowflake warehouses, as opposed to anything about storage or some of the other features in Snowflake that can drive cost. So I see a pretty big spike there that I'm probably going to want to investigate. We did recently introduce a slightly different visual representation of this, actually a Sankey diagram that lets me glean a little bit more information. So that spike in the demo environment, really accounts for half of all the compute I'm tracking, the compute spend I'm tracking in this platform. This view can also offer some ability to give you an understanding. Are there resources that we're spending money on that haven't been mapped back to an overall cost center and organizational unit? So we have sort of full coverage there. So from here, I have a couple next steps. I both want to try to avoid this or more proactively catch this in the future. And then I also want to investigate it. So on the more future-facing path, one of our recent additions is the ability to assign budgets to the different layers of this hierarchy. So dropping into an example one here, we can set budgets at the monthly, the quarterly, the annual level. They can be associated to one or more organizational units or just individual cost centers. But kind of the important piece here is when budgets are exceeded to varying degrees, you can ensure you're getting alerted of that. You don't have to just find that in the tool. So we have the ability to send this to the notification channel of choice. But that's a little bit about going forward. I do want to also dig into what happened here in the prior month. And I'm going to walk through that investigation now. I think the big highlight here as far as new functionality goes is we've done a lot of work in the last 2 releases to build contextual drill downs throughout all the different pages and areas of our spend intelligence product. So as we investigate, it'll help me carry across what's relevant to that investigation, what cost center it was for, what account it was for. Always trying to offer like a next step to further investigation. So I'm going to take that first step here. I see this spike. I want to drill into this Snowflake account and start investigating what was happening in this warehouse. So I'm pushed over to, the first page here we're looking at is a bit of an account summary. I did carry across that, I'm specifically wanting to look at this from the window of what in this account was used and sort of associated with the demo environment cost center. And one of the first things I can glean is that we were pretty consistently low on spend, but halfway through the month of February, we popped up and, then we're consistently spending a lot. This isn't a trend I would expect to see. I would expect the pre-sales team to slowly grow their usage, but since it jumped up in just one day, that seems a little suspicious to me. A couple other points of information. Again, this looks just like the compute cost. This ties out to what we were seeing in that chargeback screen. And I can also start to surface here, who are the primary users of these resources for this cost center. So I have some people that I could potentially, reach out to ask about this. But my next step here is, I really want to understand more about this spike. So I'm going to drill into specifically the compute piece here. So drilling through into our compute dashboard here, again, carrying the context of that cost center and this time period of February. I get a little bit, another layer of information here. The team working in this cost center was really utilizing Snowflake across 3 different warehouses. Looking at those over time, it looks very similar to the last chart, but additionally, what I'm gathering here is the issue was really only constrained to one of the 3 warehouses they're working on. So this compute warehouse is the one that spiked in mid-February. We have a couple of other different angles into viewing this. The cumulative costs over the month, shows the same pattern. And then some investigation into, does this look like it's, a potential issue tied to a certain time of day or a certain day of the week? And while, Mondays and Tuesdays look a little bit more costly than the rest of the week, overall, my costs seem pretty consistent across all hours of the day. So it seems like it might be maybe more of a global issue than, any new job that's running, at 5 a.m. or something on one of the days of the week. So my next step here is, well, I want to dig into the actual warehouse that's showing the problem. So landing into the, the warehouse drill down page, I start to see a lot of information here on what performance is happening in this warehouse. So different query types, if this warehouse had long provisioning times or long queuing times. But I think what catches my eye here is that this warehouse is actually using, over the course of that month, a variety of different warehouse sizes. And just, sort of knowing how Snowflake bills, going from the extra small to a medium and to a large, we're starting to get into the 4x, and then I think 16x cost multipliers when you start getting up to extra larges. So that's potentially a bit concerning. I do have the context on who my users are here as well. But I do want to kind of investigate those warehouses and compare them back to the prior month where we had costs under control. We had costs sort of as we were expecting. So hopping into January here, I was just looking at February. It kind of confirms what I thought. We were consistently using just one smaller warehouse size, and I don't see anything too concerning in queuing time that would make me think that we really needed to bump this up to a larger size. So, from here, I have some leads on the users that I need to talk to understand why they're using larger warehouses sizes, and put in some processes to avoid that in the future. So, it's great that I found a bit of a root cause here, but I'm also interested in then knowing, how do I avoid this? How do I catch this in the future? We spoke about monitoring budgets. That's potentially one avenue. It is though a little bit, after the fact. We're tracking a budget again. We're tracking spend against the budget. So there are certainly proactive guardrails that I can put in place here. And there's a couple of avenues for that in the tool. We can both facilitate in reviewing the guardrails you'd put in Snowflake itself, as well as then take some actions to apply our own through our tool. So on the former, just to pull up a few examples here, I can get an understanding of, who are my administrators of this account. I have 16 account admins here. That's probably, way too many. I need to go fix this, reduce some roles, avoid a potential case where these costly decisions can be made. We can also look at resource monitors, for example. Understanding of all the warehouses we're using, it certainly seems like an issue. I haven't put resource monitors on any of them. The compute warehouse, which is the one where we saw the issue, has one, but we didn't actually prevent anything. So maybe we need to take a look at that and tighten it up a little bit more. So while reviewing these, servicing these is good, we obviously want this to be more proactive. And it's been a conscious investment over the last several of our releases of Spend Intelligence. is to provide that more proactive monitoring and alerting, and then also offer the ability to take action on it through the tool itself. So in the context of this issue, the one that aligns to this is some of our recent warehouse sizing recommendations. So the idea here is that Excel data is pulling all the information on what queries are running, how long they're taking, the queue load, all these aspects of performance in these warehouses, and we can offer guidance on right sizing them, offering that action directly in the tool where appropriate. So the compute warehouse, it's actually still at a small, and while that's better than the extra large it was running at in February, given what we've seen, we still think you can downscale that, in even a size smaller, and we can do that right here through the tool. This will work the other way as well. If we had any very high loads, we'd offer to upscale it. And then we have sort of a light consolidation suggestion where there are a lot of warehouses out there that aren't being heavily utilized. You might look to consolidate them if you can. So this is one example of our recommendation and auto action, but there's certainly more where those come from. We ship for both Snowflake and Databricks with many monitors out of the box. The parameters of these can be tweaked, but essentially we're trying to give out of the box monitoring across the dimensions of the cost of the system, the performance of the system, guardrails that you should be implementing in the system, packaging that all up here very easily out of the box, while still allowing the user to drop into a purely custom monitoring capability where you can really go in and configure any type of alert you want based on any of the entities we're pulling in from Databricks, from Snowflake. These then can be tied to that auto actions I was talking about. So we talked about the upscale, downscale option. We're always adding more of these. Probably the most commonly requested one we had was the ability to take action on a long-running Snowflake query. So you can configure the length of query, and we can actually go and automatically abort long-running queries that are happening in Snowflake. In our most recent release, we rolled out what would be the Databricks equivalent of this, which would actually be terminating a cluster that's running based on long-running or high-cost cluster. And then one last feature I wanted to highlight. We've been talking a lot about doing investigation that started very much in the aggregate. We were slowly narrowing it down, and our newest introduction here really takes that to the most granular, a front end for looking at the individual queries themselves. And this is what we call Query Studio. So the idea here is that it's potentially difficult to understand what's happening at this granularity, just simply due to the volume of queries which may be present on a platform. So offering an interface into this that's intuitive, interactive, has precise search and filtering, paired with a level of aggregate understanding. And perhaps most importantly is a layer that we're adding on top of this, which we call query fingerprinting, which allows us to then group these queries together and making it easier to investigate and gain insights into the actual query loads that are executing on the platform. This is really needed, to tailor investigation into the query level performance that's happening on these systems. So particularly with query fingerprinting, it lets us analyze the performance as a whole rather than individually. And that lets us surface trends in the data, patterns in the data, offer insights that give us some capabilities to optimize as well. So a little bit on how this works. There are a few avenues to start when you land here. At a high level, we're looking to add contextual warehouse insights on potential bottlenecks we're seeing, whether that's across credit usage, query load, query latency, metrics like that. And then pairing that with a pretty deep faceting experience to really narrow down into distinct sets of queries. So I might narrow down to queries that are happening in a particular warehouse, generated by a particular user, and looking at a particular query type. That pretty quickly gets me to a set of queries I might be investigating. From there, I can actually drill into those queries and start to see that query fingerprinting in action. So we start to see, looking at this query, I can see how many similar queries ran in the past and start to understand in this workload, how are they performing over time on a variety of metrics, whether that's their execution time, the rows they're producing, the cost of those queries. This then lets me, sort of feed into a side-by-side comparison, which both supports debugging. So for example, investigating the reasons why a particular type of query is starting to become slower versus prior runs. But the idea is then to continue this from this investigation into optimization. So for example, Snowflake often suggests running your query at different warehouse sizes to understand, what size is the right choice. And this gives a bit of a framework to help do that type of analysis, understanding from a query load which performed best, whether best means, by execution time, by cost, things like that. So that's essentially what I had to walk through today. Certainly excited about all these new capabilities that have come out, getting them in the hands of everybody. But I did want to reserve a few minutes for any questions that might have popped up.
Awesome, great, thanks, Chris. Great demo. For those of you that are on, if you would like to put in questions in either the Q&A or the chat, that will be great. We do have a couple already, so let me just get started with those. And one of them is, how does alerting work? Do you integrate into external systems? I think you showed some on the demo, you showed some aspects of alerting, but what about integrating?
I mentioned Slack and email. I think the approach we're taking to alerting is, we're not trying to compete with incident management systems. We do manage all of the incidents we create in our platform, but then we allow you to sync those out where it makes sense. So as of today, that's Slack, email, and webhook. And then in our 2.7 release, which John mentioned is coming up shortly, that adds Microsoft Teams as well as a bi-directional ServiceNow integration.
Great. You spoke a lot about guardrails. So what about alerting when warehouses are created or edited?
Yeah, that's actually a good question. I'd mentioned this little demonstration was actually based off of something we had happen internally. And we had the same thought where we're reacting a bit. It would be nice to get alerted like anytime somebody creates a warehouse, so you can sort of observe that, edits one, changes that warehouse size. So that's definitely something we plan. The ability to do that, to pull that information from Snowflake, is actually in beta for them right now. So we're working on that so that as that moves into a feature on their end, we can certainly hop on board and provide that visibility.
Great. Okay. And then the last one, oh, actually, there's another one that came in, but the last one that I have, I'll go for now is, what about data lineage? Do you monitor data lineage?
Yes. Yeah. We didn't spend too much time on data reliability. But on the lineage piece, we pull that really two ways. As you hook up your data sources to our platform, we essentially mine the query activity we see there. And from there, we derive lineage. So we understand how the data is moving via those queries, and we can map those, across the different assets in the platform. We also then extend that. We have some pipeline monitoring capabilities where you can instrument your pipelines. We can start to monitor them for, time and reliability performance. And from that, we also gain lineage in to both the job to asset lineage that pairs then with the query to the query asset lineage.
Okay, great. Yeah, so you mentioned just now about pipelines, and so that might be a good segue into this question that came through, which is, how do we drive cost visibility at the data pipeline level?
Yeah, that's a good one. So our pipeline monitoring right now, the first steps we've taken into that is instrumenting pipelines for data reliability coverage in lineage, as well as the time monitoring, so we can provide alerting on top of, are the pipelines meeting their SLAs? I think more formally moving into the cost of those pipelines is something we want to do. Right now, there is a generic framework where you could pass up metadata associated with those pipelines for alerting in our platform. It's not tailored to costs just yet.
Got it. So that sounds like something that's in the future.
Yep.
Another question that just came through is that lineage displayed through a table or a visual graph. I think the
the visual graph. It's also available, purely over API if you need to bring that lineage information anywhere. But it's generally a visual graph, and the two views are your asset lineage, where is upstream and downstream assets, or your pipeline execution lineage, which is more about the tasks to assets they produce.
Got it. And then another one is it similar to the Databricks tools? I'm assuming they're talking about the lineage. Is it similar to the Databricks tools?
Yeah, on the lineage side, I think that our difference would be, doing this across the variety of platforms you might have, where Databricks is one source of that information for us, but we would extend that lineage, across data sources where we are able to derive it, upstream and downstream of Databricks. But conceptually, it's pretty similar to that.
Got it. Okay, great. I think those are all the questions we have. If anyone would like to, again, get one of their questions answered, please type it in the Q&A. We'll just wait a couple seconds to see if anybody types anything in. Not seeing anything come through. So I guess we're all set on questions. So thank you. Thanks, everybody. Thanks for attending. We appreciate your time today. And John and/or Chris, any last words before we close out?
No, just excited about all this stuff. 2.7's, coming in a matter of weeks. So a lot of what we were talking about here, you'll have in your hands soon.
Great. All right. Well, again, thanks, everybody. Have a great day. We'll see you next time. Bye-bye.
Thank you, everybody.